Hi students, welcome to Mithran Educational Society's Mr.PHYSICS YouTube class. Today we are going to be discuss about a topic called gravitation. First of all, we are going to be discuss about the basic fundamental nature of the forces. Based on that, we are going to be say about the gravitation topic. Okay, so first one, fundamental forces. There are four fundamental forces are there. I think all of you know that, right? First one is called as gravitational force. Second one is electrostatic force. Third one is called strong nuclear force. Then weak nuclear force. So there are four fundamental nature of forces are there. So now we are going to be discuss about the gravitational force. Among the fundamental forces, we are going to be discuss about the gravitational force. Why means that is a basic force. That is a fundamental thing also, right? That means gravitation force is the one important thing is that the gravitational force is the weakest force among the fundamental forces of nature. I think all of you know that, right? As well as it is a necessary force. Based on that force only all the living organisms is there, right? So our important thing we are going to be discuss is gravitation force. So inside the gravitation, first we are going to be discuss about many theories are proposed in a gravitation. First we are going to be discuss a very important model theories or geocentric model and heliocentric model. Okay, two model theories we are going to be discuss now, right? See, first one is called geocentric model. Second one is heliocentric model. That means the geocentric model in the sense Earth is at the center of the universe and all the celestial bodies including sun which is rotating around the earth, right? So simply we are going to be understand the concept is earth is at the center. Earth is at center. That model theory is called as geocentric model. That model theory is called as geocentric model, right? Second one, heliocentric model in the sense sun is at the center. Sun is at center of the solar system and all the planet including the earth orbited the sun only, right? In a very important point in the logic is called all are in a circular orbit. Actually it is a logic is right, sun is at center, but it is not in a circular orbit, it is in an elliptical path, right? Now we are going to be discuss that, but anyway in our solar system sun is at a center, right? So based on this, based on the Nicholas Copernicus theory, the heliocentric model, after Galileo then many scientists are there, but finally the data properly which is organized in the concept of the planetary motion by Kepler. So only we are discussing Kepler's laws of planetary motion. Very important case. Without Kepler's logic, Newton definitely he can't found the logic of universal law of force. Yeah, based on we all know, right? Based on the universal law only, electrostatic Coulomb's law is there, then Biot-Savart logics, many laws. Yeah, for all the laws, universal law is a fundamental thing. Okay, so now we are going to be discuss about the Kepler's law of planetary motion, right? After the many struggles, he found the he proposed the law, right? So that is Kepler's laws of planetary motion. Kepler's law of planetary motion. Yeah, so based on this law we are going to be discuss what are the laws he proposed, right, regarding the laws of planetary motion. So the first thing is law of orbits. Law of orbit. It is the first law actually. What is the law of orbit? It is a very simplest thing. What in a heliocentric model we are actually discussed. Some alter we are going to be do that. Okay, Kepler he did some alter in a heliocentric model. Okay, based on the data already there. He what he got in a planetary motion, right? Then what Galileo said. So all the data based on that data only the law of orbit he proposed. Actually, Kepler is a now we are going to be see the data scientist and all, right? So the same thing at the time, at the ancient time, Kepler is a data scientist, right? So he by using the telescope and naked eye, he actually get more data regarding the planetary motion of sun, moon, stars, okay? So all the celestial bodies, right? So what is law of orbit? We're going to be discussed. That means each planet, every planet revolves around the sun, yeah, in an elliptical orbit. Fine, in an elliptical orbit with sun at one of the foci. We know that. That means elliptical path in the sense like this, right? Yeah, so it has two foci. Sun is at one of the foci. Sun is at one of the foci. That means all the planet which revolves around the sun in an elliptical path, yeah, so with sun at one of the foci, right? So based on this ellipse in the sense, we know that this is a major axis. This is called major axis. This one is called y-axis in the sense is called as, this is minor axis. This is A, this is B. What is the general equation of the ellipse in the sequence? X square by A square plus y square by B square is equal to 1. Yeah, okay, that are all a different case, but we need to understand a very important theoretical terms aspect of the JE and NEET exam. Is a very important point is what is perihelion and aphelion, right? So that means when the planet, yeah, the planet which is revolving around the sun, right? When the planet which is nearest to the sun, that means when in case the planet which is moving here, right? So like this it is moving, it is come nearest to the point of the sun, right? In sense it is called as perihelion, P, denotation P, right? In case it is the farthest point of the sun, very far distance, that means here, right? This is the farthest distance, right? So this is called aphelion, right? So two things we discussed now. What are that means? The nearest point to the sun, then farthest point from the sun. This is perihelion, this is aphelion, right? So in a Kepler's law, we discussed the law of orbit. That means all the planet, all the celestial bodies revolves around the sun in an elliptical orbit with sun at one of the foci. That's all. Yeah. So based on that, from the major axis, minor axis, we draw one elliptical path. That means in elliptical path, sun is at one of the foci. When the planet which is close near to the sun, the point is called perihelion. Then the second thing, when the planet which is farthest to the point, that is called as aphelion. That's all. That's all the law of orbit. Okay. Then the second thing. Second one is called law of area. Law of area, right? So law of area in the sense, the same what we have discussed here, yeah, first logic, law of orbit. Some more additional point we are going to be discussed here. What we are discussing in the first one, that means sun is at one of the foci. planet is there, yeah, so planet is here, right? So which is revolving around the sun, that only we discussed here, right? The same thing, but additionally what we are going to be discuss means the line which joins the sun to a planet, right? The line joins the sun to the planet. For example, in a Jan month, okay, the planet, for example, it is here, starting is here, at ending time it is here. So the line joining, draw the radial vector, like this will come, right? Yeah, right? In case it is a June to July month, in the sense it is like this, right? Draw the area vector like this, right? So fantastic theorem it is, right? How we propose the theorem in the sense logic, the radial vector, right? So it sweeps the equal area in an equal interval of time. So what is the area, right, which crossed here? The same amount of area should be here, the equal area in an equal interval of time, right? So then main thing is so how's the equal interval of the time? In the sense, see, whenever the planet which is close to the sun, that is in a path of perihelion, right, point of the perihelion, whenever it is close to the sun, nearest to the sun, it moves very fastly it will move, right? In case it is very far to the sun, that is a aphelion point, right? So at the time it travels slowly. So the logic is same, right? So that is area, equal area in the equal interval of time. That means the rate of change of area should be constant, he said, should be constant. Yeah, it should be constant. We understand that one, but how it is possible? In the sense, whenever it is in a perihelion point, each and every term is important for the for JEE and NEET aspect for problem solving, right? So based on that, now we are going to be derive one important thing that is a very important case, right? So listen, so whenever it is moving, right, like this is a perihelion point, this is a aphelion point, right? Here it is moving very fastly it will move, here slowly, right? So two different cases are there. Now we are going to be discuss whenever it is moving in a like it is an elliptical path, okay, no problem, but the forces is there, the force is perpendicular to the radius of that vector. That means definitely some amount of torque will be produced based on the system of particle now only you completed, right? Okay, so what we are going to do, what is the amount of torque which is produced by the planet, then what is the angular momentum, right? We are going to be seen, because it is moving in a elliptical path, right? So definitely it is moving in a somewhat, it is nearly close to the circle, ellipse in the sense it is close to the circle, okay? By the logic of the Newton's law, we can understand that one, right? So now what we are going to do means, first we are going to be find the area, okay? So area in the sense general formula, it is like a triangle, okay? So this point we are going to be considered as a right angle triangle, okay? Somewhat bend, but it just consider this, okay, right? This is dl, change in length, okay? So this is the radius, right? So it is the formula, area of the triangle half b into h, that means dl into r, correct, right? Half dl into r, fine. So in a motion in 1D logic, we discussed whenever it is moving in a circle, motion in 2D logic, whenever moving in a circle, right, how we are going to be find the angular displacement in the sense that is called as plane angle. So that means theta should be equal to arc length divided by radius. I hope all of you know this, right? So arc length in the sense, this is dl divided by r, yeah? So what is dl? What is dl? Theta into r, am I right? Theta into r. So substitute the theta into r in second equation, okay? This is first one, second one, third one, yeah? So substitute substitute 3 in 2. Yeah, so once you substitute, what is the answer will come here? Area is equal to half into, instead of the dl, r into theta into r. That means half r square theta. Am I right? Half r square theta. That means whenever the length will be changed, definitely the theta is also going to be changed. The radius is constant, because in a circular path, in the sense it should be the radius, right? So as constant, so we are going to be use d theta, change it. Okay, once we found what is the value of the area, right? So this value of area we are going to be substitute in first equation. Okay, so substitute 4 in 1, correct? So what is 1? dA by dt is constant. Yeah, so we are going to be substitute that. How we are going to be substitute? See, dA by dt is constant in the sense half r square d theta by dt is constant. Am I right? Instead of I am going to substitute that. Fine. So d theta by dt, that is rate of change of angular displacement, correct? The rate of change of angular displacement is called as angular velocity. Am I right? So substitute that. Instead of that, half r square into omega is constant. Is constant, right? So in this condition, we are going to be multiple and divided by m, means the equation will not going to be changed. Why sir we are going to be do that? Means because the planet only is moving around the sun. Yeah, the planet mass is not going to be changed. So we are going to be multiple that, based on that mass particle only, that planet mass only is going to be revolving around the sun only, right? So what is the angular momentum, right? Based on that, what is the rotating force we are going to be find. So only mass we are going to be taken, right? So now half m r square into omega divided by m. Am I right? So what is m r square? M r square in the sense is called as inertia, right? We discussed, right? Mass into the perpendicular distance of square is called as inertia, system of particle. So based on that only the gravitation is there. Okay, right? So substitute half I into omega divided by m is constant. Now what is I into omega? I into omega, that is mass into, is like a mass into velocity in a linear concept. Yeah, so linear concept, mass into velocity is called linear momentum. Same thing here, moment of inertia into the angular velocity in the sense is called as angular momentum, L. It's called angular momentum, L. So substitute half L divided by m is equal to constant. So mass is a constant because what planet it is? For example, it is a sun, it is a Earth, yeah, or Mars. So the planet mass should be constant value, not going to be changed, right? So the mass is constant, 2 is constant. So L is equal to, if both are going that side, means K is already constant. So constant to constant only come. So K, L is equal to K. That means constant. That means angular momentum, right, for the radial vector which sweeps equal area in an equal interval of the time of Kepler's logic, the angular momentum is always constant. When the angular momentum is constant in the sense, what about torque? What about torque? 0 only, right? Yeah. So the rate of change of momentum is called as force. Rate of change of momentum is called force. If momentum is constant, that is not going to be changed, means how the force is going to be changed? So nothing is going to be changed, so it is 0. Right? So it is not going to be changed. Yeah. So this is second law of areas. Right? So third one. Once we understand the logic of second one, it is very easy to understand the law of periods. Actually, the first law, second law, and all okay. Based on the Nicholas Copernicus theory, heliocentric model, Kepler he found the law of orbits. Some he did research, yeah. He analyzed all those things based on that. Okay, but heliocentric model theory helps to fulfill the concept. But the law of period is a very interesting and amazing theorem here, because how we found this, okay, without any mathematical logic is there, yeah, without any mathematical knowledge, logics, and no proper instrument is there at the time, but he found this law of periods is a very important. Based on the law of periods only, Newton he proposed the logic of universal law of gravitation. Without the law of periods, Newton can't able to find that, right? So in a problematic topic also, in a JE aspect, whenever Newton's logic they are going to be asked means, okay, the inverse logic will be happen. The inverse logic in the sense how Newton proposed this based on the Kepler's law of period only, right? He's approached the theorem. Okay, so it is a very important thing. What he proposed in a law of periods means the square of period of the revolution of the planet around the sun, is that right? Yeah, that is the time taken to take the planet which is around the sun. That means that is a square times, he said, that is a square times, yeah, it should be proportional to the cube of the average distance of the planet from the sun. That means it's a semi-major axis. That means it is called semi-major axis, yeah. So see, I explain a diagrammatical format. It is in an elliptical path, right? So sun is here, a planet which is going to be from here to again it is come here, means it is a one complete revolution, right? So for the time period square, yeah, that should be equal to, directly proportional to the semi-major axis. Semi-major axis, this is called semi-major axis. Totally it is a major axis, half in the sun, that is called semi-major axis, right? A, we know that the distance increases, definitely the time is going to be increase, yeah. So distance increase, for example, Earth it takes 365 days to complete the revolution in the sense, yeah. So Mars definitely takes more than that, Jupiter more than that, Saturn more than that. So compared to Earth, the total distance is very high, so time taken is more, yeah. So that only based on that logic he proposed, directly he can say T is directly proportional to A in the sense, no, it's a very simple thing. But what he proposed, T square is directly proportional to A cube, right? That is square of the period of revolution of a planet or a celestial body, right? It is applicable for all the celestial bodies. Even satellite we are going to be send means also this logic will applicable. Again I'm saying the very important case, very important case, right? Mostly JE and NEET level problems, gravitation topic they are going to be asked in the sense, mostly they are going to be targeted in a satellite thing, right? So that also, what is the speed, right? What is the distance, right, from the Earth? What is the distance of the satellite, or what is the speed of the satellite is revolving, the orbital speed, like that only mostly questions will become. But for all the logics, no need to remember all the formulas. Once we understand the concept of Kepler, that is enough. For all the logic, that is enough, yeah. So the amazing thing here only will come. What does that means? T square is equal to we are going to change means a constant, right? A cube. That means T squared by A cube is constant, right? So that constant value, right, approximately should be equal to 3. The constant value approximately should be equal to 3. This will help you more. This value will help you more. The law of period in the sense, okay, this value is important, right? So somewhat you can understand what is Kepler, what he proposed in a logic of Kepler's law, planetary motion. Definitely, it is not a full theorem. Okay, so based on the Keplers we are going to be discussed means the day is not enough. What he already found. Okay, that and all we are going to be discussed means the day is not enough. But as per our syllabus, okay, we discussed what is Kepler's law, how we can remember the logics, what are the important points we discussed, right? So thanks for watching this video. We are going to be continuing in the next class. Okay, thank you.